So one of the main things that we're going to be using in this course is a scatter diagram. So when we have bivariate data, we're going to put some of the variables on the x-axis, like our age, when we're looking at bus maintenance. And then over here, we're going to look at the maintenance cost. And so we find that as buses get older, they start to have higher maintenance costs, right? And so this, we would say, is a positive relationship. As things get older, they cost more money to maintain. And if we were to draw a trend line through this, it would probably be something like this. The next type of scatter diagram that we're going to be looking at often is going to be a scatter shot. So this is a situation where there is no clear trend in the data, little or no relationship between the two. So if we looked at batting averages for baseball players, and then we look at the home runs that those baseball players get, we're going to see this relationship that looks something like this. So there is no clear relationship either going up or going down. This is just kind of a scatter shot. It's a scatter shot, scatter diagram. So in this, there's no relationship. And there's no trend line for us to estimate. The last one is, you guessed it, going to be a negative relationship. So this one is if we're looking at the housing prices and we're looking at the days on the market, right? We tend to find that if your house has been on the market longer, the price that you're able to get for it is lower. And so if we were to look at a trend line for this particular situation, we would find that the line that best captures this distribution of data is negatively sloping. Because why? Because there is a obvious negative relationship in the data that we are given. So how do we measure how much these two variables move together or differently? How do we measure how much these two variables move together or differently, right? Well, we use this thing called a correlation coefficient. So a correlation coefficient is going to measure the direction and strength of the relationship between two variables. And so our formula for our coefficient, our correlation coefficient, number one, our correlation coefficient is going to be abbreviated with a lowercase r here. So lowercase r. And what we're going to do is we're going to take a sum of how far the x's get from their average, and we're going to multiply that by how far the y's get from their average. And then we're going to divide this whole mess on the top by a n-1 degrees of freedom times the standard deviation for x times the standard deviation for y. So this variable, right, this r variable, it can range from 0 to, or sorry, it can range from -1 to +1. The closer it is to those extremes, the stronger the relationship. So if it's a coefficient, it's a correlation coefficient that's 0.95, that's a very strong negative relationship. If it's positive 0.95, it's a very strong positive relationship. If the r is 0, that means there is no relationship between x and y. So if we have a situation where every single value that we have in our scatter plot falls on this line, right? So if we have a bunch of values that are like clockwork, consistently one up and one over, then when we draw a line in between there, the line is going to be on top of every single point. So this particular one, we're going to have an r that's equal to positive 1.00. So this is a perfect positive correlation. We can compare this to a situation where we have, again, like clockwork, every point is one down and one away. And so we end up with a trend line that passes through every one of these points. And this particular situation would be an r of negative 1.00. We would call this perfect negative correlation. Why is it negative? The slope is downward sloping, and the relationship between the two is inverted rather than being direct. Again, you're going to have some practice with this in your homework if you haven't already. With all of these things, you can do them in Excel, so you can download the data files and do them in Excel. It is much faster, but some people don't find it easier. Some people like to do it by hand. So for all these things, you can do them in Excel or you can do them by hand. And sometimes in Excel or Google Sheets, you can even kind of check your work by using a formula that will do all of the calculations for you. You can't always rely on that because sometimes the formula that is doing the calculations for you is using a slightly different format, right? Slightly different underlying formula. But there are, you can, again, check your work with it. So don't try to come up with the final answers for the homework with it because you're probably going to be led astray. But you can check your work with it, or you can do the steps that you've been doing by hand. You can do them in Excel or in Google Sheets and check your work easier and just kind of get through the questions faster. It's one of those situations where it might be more difficult and take more time the first few times that you do it, right? When you download those data files and do the calculations in Excel or Google Sheets. But once you start to do it, you will end up saving time over the course of the remaining weeks.